All right, I'm gonna quickly talk about the cross product. Quickly because it's getting late and I got uni at like 9 tomorrow. So A cross B, that's how you write it. That's how you pronounce it, A cross B. And it's a bit of a weird one. It comes out as a third separate vector. And the weirdest part of it is that it's perpendicular. So if you've got this one going there and this one going here, then the cross product's gonna be up there or it's gonna be down there. And it depends. I'll rub this out now so you just sort of understand it. You gotta notice like that's one plane, that's like the other plane, and then that's like the top plane. You see, it's like perpendicular. So it's always perpendicular. And you remember how when we were talking about this one, this was a scalar quantity, remember? This is a vector quantity. So this one that comes out, that's gonna have magnitude and direction, all that shit is gonna be like in the form like I plus 7j plus 3k or whatever. But this one here, we were measuring how connected it was. So if this is the first vector and this is the second vector here, they're very aligned. So it's basically just going to be magnitude of A times the magnitude of B. But if we had a second pair of vectors where they weren't aligned at all, that's not aligned in the slightest. That's going to be A times B, and then it's going to be cos of this angle here, cos of theta, and that equals 0. So they're not aligned at all, so you get a score of 0. It's very different with the cross product. Cross product, you want it as far as possible. So it's actually, it uses sine theta as the useful part of it. And the way you can think about that is that it's used a fair bit with torque, with screws. So let's say we've got like a hex head screw here. That's the worst hex I've ever driven. Okay, so then you got a spanner that looks like, kind of like, I don't know, like that kind of. And then you've got this. So this is used all the time in like mechanics, screw mechanics, but whatever. So this is the direction of the handle, R, and this is the direction of you pulling it. Okay, so if you wanted to say how aligned it was, so if we were just using the cos theta thing, if you want to say how aligned it was, you're gonna get nothing turned to that screw. So the outcome C here is the screw, how much it turns. If you go that way, you're gonna get nothing. So R cross pulling equals nothing. But if you go in completely the opposite direction, this pulling, you're gonna get something, and that something is magnitude C, and then like a weird perpendicular thing that you add up. So it's gonna be like into the page or out of the page. The way you figure out which direction it is use like the right hand rule. I'm not really gonna teach you up. There's very good diagrams on Google Images for that. But yeah, so basically the thing about the cross product is it's good for telling you like perpendicular, like I just give you two vectors and you do some special things, and then you can tell exactly where the perpendicular part of that is. If it's out of the page, if it's into the page, if it's like sideways and up, or like, you know, diagonally and down. And it's also good for giving you a measurement of how unaligned something is. So if it's 90 degrees, it's good. So how right angly it is. That's my adjective. So it's good for that too. Yeah. So this one here, when you pull this spanner like diagonally, some of it's going to count, and what's the sum of it that's going to count? It's going to be this part of that. which if you're looking at the pulling force and you say that that's R, and you're talking about theta here, it's this bit here, which is sine theta, which is the pulling force times sine theta. So how right angled it is.